Hey everyone, this is your friend Bill Greeter. I just thought that our help session yesterday was a bit of a mess, so I thought I'd just do it over again and put in a quick video for you. Again, now we're looking at seven, actually eight homeworks, that have been assigned, and I just want to kind of take you through them. As I mentioned yesterday, I think really early on, we did Pareto, and that was where I gave you some, kind of a budget, a fake budget to find out what the 20% of the items would represent 80% of my expenses and make a recommendation. So if you haven't done that one, that's pretty simple. SIPOC was about picking a process. It could be anything from cooking breakfast to mowing the lawn to feeding your dog, whatever you wanted to. And with SIPOC, we start with process, then we work back to inputs, then we work back to suppliers, then we do outputs and customers. But again, I think this is another one where this was early on. I think everybody was pretty much caught up. Descriptive statistics, there's a couple of things that were going on, homeworks that were on this particular slide. Originally, we had only had the dates and weights. And there I wanted to just go through and get the max, min, range, mean, mode, median, standard deviation, variance, and Z distribution for all those. And you can see the formulas there. They're as soon as I click on it, you can see in order to get max, it's equals min. Then this max minus min gave me my range. And then the average or mean, that's equal average of all my data for weight. The mode is the one that happens the most often. The median is the data that lands the most often, the one it shows up the most. And then standard deviation is the average deviation from the mean for all of my data. And that's pretty important, as you can see. And then the variance is that squared is actually the standard deviation squared, or you can do it equals var dot p, which is population of all my data. And then the Z distribution equals norm dot distribution, and then it asks you for some inputs. And that's what those are. So what I wanted you to do for homework was take my data and draw a Z distribution for my data, nice bell-shaped curve. The other things that we've done on this was one, we got into using the data pack, which is data analysis pack here, in order to give us a lot of those same descriptive statistics. So you can see here, mean, and widen it up a little bit. Median, mode, standard deviation, variance, min, max, number of count, 7724. And then also when we finally we got the correlation. This was another homework where I was asking if there was a correlation between a pulse over all this data and the weight. And we ended up with a big block like this, a blob of just blue dots. And then the regression analysis one was basically just taking that blue dots and drawing a trend line and also having the formula show up. So just a quick review on that one. I'll just eliminate that. And so once I have my data all in a blob, I just right click, add trend line, and then this pops up. And there's a bunch of things I can do. I want to display the equation. Just click this box, display R squared, and then I can format my trend line too, make it yellow so I could see it. And I'm gonna make it a little bit, type is gonna be solid line. We'll make it a little bit thicker so it really shows up. And so it looks like, there it is. So I just took the formula and move it over so you can see it. Just a review. This formula, this Y formula, 0.2107x. That's the slope of the line, which is the rise over the run. In other words, with the angle of this line, we know that this is a weak positive correlation. And then plus 170.85 minus one. This is plus 170.85. So that's going to be where this yellow line crosses the y-axis. That's the y-intercept. And with those two pieces of data, I know I can draw the line confidently and what it looks like. Otherwise, very difficult to draw the line, obviously. The other part of the homework was to use the data analysis pack 2 to do the same thing. And you'll see here that using the data analysis pack with that data, I end up with a weak positive correlation between my weight and my pulse. All right, so that was a couple of homeworks that were wrapped up into this one. Again, so I covered so far Pareto, SIPOC, descriptive statistics, correlation, and weight. There's a third way to get correlation, and that's equals Correl. I double click that, and then it's going to ask me for this data and this data. And you see I got the same 0.375 that I got here and what that I got here too. That's my R squared is that 0.375994 squared. That's where the R squared comes from. So far we covered again Pareto, SIPOC, descriptive statistics, correlation, trend line, and R squared. And then the last ANOVA, this is where I really I don't know why yesterday during the review session, the only homework here was to find out what my F statistic is, and to find out, and don't remember, ANOVA is looking at data, and this happens to be discrete data. This is stress data for 3 different shifts. So obviously these aren't something you can measure, anyway. It's more of a rating of stress levels. And we want to know what's the variation. ANOVA means analysis of variation. What's the variation between the data in the shift and also between shifts? And the video that I sent you guys, it takes you through this long formula in order to come up with the F statistic. The homework here was just to use the data pack. And this is where I really stubbed my toe yesterday, as you guys remember. And I hit the data analysis pack, ANOVA, single factor, hit OK. And then here, I'm just going to take all this data, including the headers, because I got labels in the first row. I'm looking at an alpha value of 0.05, or same thing as a 95% confidence level. And I'm going to put it, I'll put it below the graph. I'll put it right here. I don't know why. Let me do it again. Excuse me. I put the output range there. So here I'm going to put, so we're going to go right here again. And then my input, I'll put it, back it up, down here. And I'll hit OK. And there it goes. Perfect, right? And all I want to know is so basically, this is a type of a hypothesis test. And we want to know, the null hypothesis here is that the stress levels for these 3 shifts are equal, right? That's my null hypothesis. The stress level of first shift, second, and third are all the same. And the alternative hypothesis is that they're not the same, statistically, at a 95% confidence level. So you can see 4 to 12, 9, it counts for me. It gives me averages for them and what the variance is. But then down here, there's 2 things that this gave me. One was the F crit, which is what comes out of this table on the right, and the F statistic, which is 12.9. Now, if you think about the F crit as being the goalpost on one side, the 12.99 is way into the rejection region, right? My F critical, which is from the table, tells me where the rejection region starts. So it starts at 3.29. This is way to the right, 12.994. If you just picture a bell-shaped curve, and we're looking at the rejection region on the right. When do we reject the null hypothesis? So in this case, we would reject the null hypothesis because the F is way in the rejection region. So by rejecting the null hypothesis, we know that the stress levels for these 3 shifts is not the same, and they differ. Doesn't tell us how they differ, but we know that there's different stress on different shifts. All right. And then the last homework, and this is the one that we just did, is due this week. And I'd really like you to hopefully have fun with it. And that's to go through and do a control chart. And I know some of you have already submitted to me for my weight data. So anyway, I hope that's better than we did yesterday. That's a review of the homeworks. Again, this math practice is meant for you to be able to have all the things that we've learned all in one simple area. Right? So if you ever have to refer back to it, you can just go to this and say, aha, maybe I got it. Right. So anyway, have a great night. I apologize for the hot mess yesterday. Hope this is better.